Hello everyone. In last video, I have talked about certain, you know, questions of permutation, and today again I'm going to deal with more questions of permutation. So let's understand this one more question: how many words can be formed with the help of three consonants and two vowels, and such that no two consonants are adjacent? And this is an important condition. No two consonants are adjacent. That means none of the consonants actually are coming together. You can think the problem this way that I've got five items with me. I've got three consonants and two vowels. So I'm representing consonants by one, C1, and let's say C2, and then comes C3. So these are the consonants. And I want to form the words, and of course, the condition is none of the vowels actually should, none of the consonants should be adjacent to each other. And they should not appear together. In between each of the consonant, there should be a vowel. That means between C1 and C2, there should be a vowel, and C2 and C3, there should be a vowel. Now, the problem seems very much straightforward to me. I've got, like, say, three consonants. So you can think about that out of three consonants, in how many ways they can be arranged actually at three different places, and how many ways these two vowels can be arranged at two different places. So fundamentally, three consonants have three places to get arranged. So they are going to be arranged in uh, three ways. And this happens. And the next thing, that two vowels can be arranged in two C2 ways. So these are the total number of possible ways, total number of possible words. So it's pretty simple to understand that there are three constant consonants. Actually, they have three places where they can be arranged in three ways, and there are two vowels. They can be arranged at two places in two C2 ways. If you solve it, it is, I guess you understand the formula for permutation already. And this is again going to be 2 minus 2 factorial, and it's going to be 3 factorial divided by 0 factorial, and this is going to be 2 factorial divided by 0 factorial. So that is going to be 3 factorial times 2 factorial, and if you are going to solve it, something like 3 times 2 times 1, and this is again 2 times 1, and that gives you a 12. So there are 12 possible words in such a way you can make. Let's see another question, and this particular question actually asks you that how many numbers consisting of two digits can be formed with the help of digits 1, 2, 3, 4. So I've got, let's say, four digits with me. So n is simply 4, and I have to make a two-digit number. So r is actually equal to 2. Each number contains 1. So if each number is going to contain one of a two-digit number, then I am left with, what, one place is always fixed. That means I'm going to get one in each of the number. So one is already gone, then I'm left with three numbers, and I have to pick one out of them. And if you could see the previous video, that is very simple to understand. And diagrammatically, I can show you that there are four digits, and out of which I have to pick two digits to this. So this is n, this is r exactly, and I have to pick two digits to form a number, and one is going to be there. So one place has already been occupied by one, either this place or this place. I mean, since it is a two-digit number, either one is going to come at first place or at second place. So this has already been occupied. So one is already fixed in all these things. So out of rest of the three numbers, I have to choose one, and that I simply can do it in 3p1 ways. And 3p1 ways, I can select a number here, and one actually has already can occupy one of the two places in two ways. So, total number of ways. This is the first part which I am doing, right? So total number of ways, number of I would say number of numbers, you can write it this way, numbers consisting two digits, they can be given by 2. These are the places which are occupied by 1 times 3p1, and simply you can solve it like 2 multiplication 3 factorial 3 minus 1 factorial, and once you're going to solve it out, that is going to give you 6. Let's see the second part of this particular problem. Let us understand the second part of this particular problem when it says no number contains 1. So I'm rewriting the entire concept. N is equal to 4, R is equal to 2, and I have got 1, 2, 3, 4, and I cannot select 1. That is very simple, because simply it says none of the numbers should contain 1. So the problem reduced very, very simple. I have 3 numbers left, out of which I have to choose 2. And they can be picked up 2 ways. And that is simply 3 factorial divided by 3 minus 2 factorial, and this is exactly going to come out to be 3 factorial by 1 factorial, and if you solve it, it's going to give you 6. So 6 possible numbers of 2 digits I can form which exclude 1. Let's see the another problem, and this particular problem actually tells you that how many words can be formed with the letters of word validatory, provided that the letters A, E, L, O, Y are not separated at all. That means they stay together. So let's write the letters which are going to stay together. A, E, L, O, Y. They're never going to leave each other's side. And what are the remaining numbers I have? The remaining numbers I have, remaining letters I have with me are V, L, D, C, T, and R. So if you see V, L, D, C, T, and R, and of course A, E, L, sorry, A, E, L, O, Y are going to stay together. Okay. That's something I've done wrong. Let me redo it. How to redo it? So I've got A, E, L, O, Y sticking together, and I'm going to put it with another color. What are the left letters? So I've got V, which is not a part of this. A is a part of this. Then I've got L is a part of this. E is a part of this. D is not a part of this. I is not a part of this. C is not a part of this. T is not a part of this. And R is not a part of this. So if you see this entire concept here, that these yellow letters are going to stay together all the time, while if I talk about the other ones, they can actually shift here and there. So I can take this problem as how many letters I have to actually arrange. This I can consider as one group. Then I have got 2, 3, 4, 5, 6, 7. So 2, 3, 4, 5, 6, 7. So the one problem is very, very simple, that these 7 needs to be arranged all together. So they can be arranged in 7p7 ways. That's one part of the problem. Second part of the problem explains that these five can also be shifted amongst themselves. They can be arranged amongst themselves in 5p5 ways. So my answer is very, very simple here. I'm going to get the number of arrangements. They can be 5p5 times 7p7, and that is exactly 5 factorial times 7 factorial if you solve it. And once you're going to solve it, it is going to give you 604800. These are the possible words can be formed by keeping these particular letters together. Let's understand another problem. Out of letters A, B, C, D, A, B, C, P, Q, R, how many arrangements can be made beginning with a capital? So that is one part. And second is beginning with and ending with a capital. So if particular, so I have got, let's say, n, how many exactly number of total items I have? I've got 1, 2, 3, 4, 5, 6 items in together, all together. Now it says beginning with a capital. That means first place is always fixed with a capital, and I'm left out. So I can choose the word to begin with out of these three letters, right? So I have three capital letters A, B, C. Out of these three, I can choose one letter to begin with, and so that can be selected in 3p1 ways simply. That means I can simply select A, B, or C, whatever it is. So the first letter can be selected in 3p1 ways because I have three capital letters out of which I can select one. And apart from that, if you see, remaining letters are how many? So one is fixed. Now I have got 1, 2, 3, 4, 5. You know, so the biggest confusion which actually student goes through in these kind of problems is they think that the capital is once used, they cannot be reused. But in the problem, there is nowhere it is given. That means it has to begin with a capital letter, but in between anywhere a capital letter can also come. So I have five more places, five more items left with me, five more words left with me, and these five particular words can be arranged in 5p5 ways. So this is my answer. So if I see 3p1, it's going to be 3 factorial divided by 3 minus 1 factorial, and 5p5. These are some direct results you can use. You know, it is always going to be 5 factorial divided by 5 minus 5 factorial, which is 0 factorial, and it will come out to be 1. And this is definitely come out to be 3 because it will be 3 factorial divided by 2 factorial. So this is 3 times 5 factorial, and if you're going to solve it, uh, this is going to give you a number 360. So this is the first part, beginning with capital. Now I'm going to do the second part, which actually says you that beginning and ending with a capital letter. So now I've got like first place and second place. These are the two places, and out of these two places actually, first and second, first and last can be, out of how many capitals I have? Three, A, B, C. So these two places can be selected in 3p2 ways very simply. And if you see, then remaining four, because two places are occupied by capital letters, now I'm left with any four. So these 1, 2, 3, 4 places, they can be filled up by remaining four letters in 4p4 ways. So if this is the second part which I'm doing. So if you see how many possible ways it can be done, it can be done as 3p2 and 4p4. These two things happen and it is going to work out. 3 to p2, again it is going to be 3 minus 2 factorial, which is 1 at the bottom, and this has come out to be 4 factorial. So it will be 6 times 4 factorial, and which is going to give you 144 possible ways. So certain problems of permutation, which actually gives you a flavor of different things or different principles of permutation that can be adopted. In this case, one more question is there where I have the number of arrangements that can be made out of the letters of the word accessory. So if you see in this particular way, there are 13 letters in that. So if you can count them, there are in total 13 letters which I want to arrange. And out of 13, I have to see how many repetitions are there. So if you see how many, like if you see A's, they have been repeated thrice. So there are three A's, and apart from that, four S are there. And if you see, two I's are there. So you can see that two I's are there. And if you see, there are two N's also. So I've got 1, 2, 3, 4 repetitions. So number of words, if you want to keep it, I've already said, then it is going to be 13p3 because I'm arranging 13 out of 13 divided by if you see 3 A's actually, so that need to go out. That means because I'm just removing the repetitions, so they are going to occupy 3p 3 P's, and then 4s 4p 4 ways can be, you can take, and it is 2c2. And actually these n's, which are exactly how many n's, if you see there are two n's, right? Two n's, I forgot to write it here. So 2c2 2p 2 ways. Okay, just need to make some correction here. 2p 2 ways are the number of n's. So it is going to be 13 factorial divided by 3 factorial, 4 factorial, 2 factorial, and a 2 factorial once again. And you can solve this entire problem. It is going to give you something like 1081080 possibilities. So if you see that, then in that case number of repetitions actually comes at the bottom, and because it is cancelling the repetition of the words. And that's how a problem with repetition, without repetition, including a particular word or letter, or removing, excluding a particular word or letter, can be solved. So these are all problems for permutation. Thank you very much.